If you are like me, you must be sick and tired of all the BS in the web dev space after years of doing it. With all its front-end frameworks, back-end options, styling solutions and rendering strategies, it really is hard to stay up to date in this world. This becomes even more frustrating when you want to remove all the background noise and simply build stuff. So in this video we'll do just that. We'll remove all the unnecessary complexity and build a scalable, state-of-the-art app using a minimalist tech stack. We'll use the Go standard library on the backend to capture incoming HTTP requests, handle our business logic, and return HTML to the client. Then, in the response, we load up HTMX and then easily trigger async requests for a great user experience on the front end. That's it. Really. This is the entire stack, and by the end of this video, you'll be amazed by how simple yet powerful this actually is. After all, this app is HTML first, server rendered, network efficient thanks to the lightweight HTMX, and scalable thanks to the power of Go. Without further ado, let's make sure Go is installed on your machine and then initialize our project. For future reference, we'll execute our code using the go run command, which accepts one or more Go files as the target. Most of our backend code will be placed in main.go, and I'm storing the HTML files under templates. Of course, our app needs some styling, so I'm going to define an index.css file under the static directory. In the main.go file, let's import the template module to compute our HTML, logging, and the HTTP module to handle HTTP requests and responses. Next, in the main function, we'll make sure that any call to static assets will be correctly resolved to our static directory. This is how the server will know how to resolve requests to images or CSS files. Then, when a user makes a call to the root path, we'll use the template module to retrieve a file from the disk, compile it, and send it as the response. Finally, we call the listen and serve HTTP method, and we have our HTTP server running. By the way, a few weeks back I posted a video showcasing a similar stack, but with Go Fiber as the HTTP engine. Just like Java developers hate it when you don't use enough factories, Go developers hate it when you don't use the standard library. So we'll just stick with the basics in this video, which, as any Go developer will enjoy pointing out, is more than enough. Back to the code, our root path is resolved to a template/index.html file, so let's go ahead and create it. The app will allow users to search for various companies, look through the results, and then add the relevant results to a favorites list. Since HTMX is also present in the page, we can augment the default input behavior so that whenever the key up or change events are triggered, an async request to the search endpoint will be sent to the server. Then, when the response is received, the HTML will be placed inside the search results container. Back in the main.go file, let's add a new handler for the search endpoint. This time, we'll compute the HTML based on the results fragment and the response received from the third-party Polygon.io API. Quick side note, I'm handling all the third-party API integration in a separate stocks.go file where I'm defining a couple of structs and then simply performing HTTP calls to Polygon.io. The resulting JSON is unmarshaled into our own data structures, all via the Go standard library. Back to our search handler, the key is received as a query parameter, and the obtained data is used to compute the results HTML. This HTML page is just a fragment, which will be placed inside the main index.html file, as I mentioned a second ago. Here, we'll iterate over the results, display the company name, and then render an add button. This one triggers a post request to the stock endpoint and appends the resulting content at the end of the stock list element. As for the handler, let's make sure we are addressing the correct request method, retrieve the ticker from the request body, and then only compute the stock element block inside the index.html file. FYI, this is where you'd probably want to store the information in the database and maybe add some other REST methods like put or delete. Now we can start the server and see the application in action. Pretty neat, right? If you found this video useful, you'll probably like some of the other videos on my channel. Please like, subscribe, and until next time, thank you for watching.